Inside every computer is a central processing unit, and inside every CPU are small components that carry out all the instructions for every program you run. These components include AND gates, which only allow electricity to flow to their output wire if all their input wires are on. The AND gates use tiny transistors to control the flow of electricity to the output wire. The electricity from another part of the computer flows in from the top and gets stopped at the first transistor unless its input wire is on. When that input wire turns on, it causes an electric field to form around a small piece of insulated metal. This electric field reaches out past the insulation and causes the properties of the semiconductor material below it to change, turning a small part of that semiconductor into a full conductor, bridging the gap for any electricity flowing in from the left and out to the right. The types of components you create from transistors are based upon how you wire their inputs and outputs together. If you chain them together so that the output of one flows to the input of the next, then you are creating an AND gate, where all the input wires must be on for the final output wire to be on. Inside the Scott CPU, you'll see a number of these AND gates scattered around, with some having more inputs than others. Another type of component that you'll come across is the OR gate, which is represented by this shape. Instead of chaining the output of each transistor to the input of the next, you instead run all the output wires to the same place, the output of the whole gate. In this way, if any of the transistors have their input wire on, then electricity flows straight through them to the gate's output. You'll also see a number of these OR gates scattered around the Scott CPU. By the way, the Scott CPU comes from the book But How Do It Know by John Scott, which is available at his website, buthowdoitknow.com. It includes a great explanation of how computers work for beginners, and John was kind enough to allow his CPU design to be used in this video. The other basic component you'll see in any CPU, including the Scott CPU, is the NOT gate. The NOT gate uses a transistor to divert the electricity already flowing to the output of the gate to a ground wire, effectively short-circuiting the output wire, turning the output of the gate off if the input wire is on. There are a number of these NOT gates inside the Scott CPU, not only in the locations seen here, but also inside the other components. For instance, the stepper component is just a particular combination of AND, OR, and NOT gates, where the output wires turn on in sequence each time the input wire to the stepper turns on. This input wire comes from another small component called the clock, where the output wires turn on and off again very quickly in a steady pattern. The only other component used in this part of the CPU is the selector, formed from another combination of AND, OR, and NOT gates that turn on one of several output wires depending upon what input wires are on at the moment. In another area of the CPU is the arithmetic logic unit, which includes more AND, OR, and NOT gates, along with the selector component that we just saw. There are a few other components in the ALU, like the exclusive OR and the NOR gate, but these are just made from the same OR gates we saw earlier, along with some AND and NOT gates. In other videos, we'll see how these components work together to process instructions sent to the CPU. This has been a brief look at what's inside the CPU.